Pathways are conceptual units of the metabolic network. At BioCyc, we define pathways in part based on evolutionary and regulatory boundaries to increase the accuracy of pathway prediction in sequenced genomes. Let's begin by entering the Pathway Search tool and search for tyrosine biosynthesis. Note this search tool lets us search for pathways according to many criteria, such as the number of reactions present in the pathway or the substrates present in the pathway, and that we can combine these criteria as well. Furthermore, this page lets us generate a list of all metabolic pathways in this organism. But we'll keep the search simple for now and just specify tyrosine biosynthesis. And ignoring that error, we got two results. One is a class, an ontology class. The other is an actual pathway. Let's click on the actual pathway. We are now on the pathway page for tyrosine biosynthesis. At the top are the organism name and the name of the pathway, and an evidence code for the presence of this pathway in this organism. And note we can click on the evidence code and in some cases get more details such as a citation, although not in this case. The pathway presents a series of reactions and metabolites. They're all clickable, so to go to a metabolite page, we could click on the name of the metabolite, and to go to a reaction page, we could click on the arrow. There are also tooltips for each of these entities that give more information about them, such as synonyms for their names and their unique identifiers. In green are the names of related pathways that connect to this pathway. We show information about the regulation of this pathway when known using the plus and minus symbols, and you can mouse over a plus or minus symbol to find out what is regulating that gene or enzyme. We can also produce more and less detailed views of the pathway diagram with these buttons. More detail gives us a more detailed view that includes chemical structures, for example. In this case, we get the chemical structures along the backbone of the pathway, and if we click more detail again, we'll get chemical structures for all of the metabolites in the pathway. Well, except for very large common metabolites like NAD. Now, if we click less detail, we'll get back to where we were, and we can produce a still more collapsed version of the pathway if we want to see that. Scrolling down, this diagram shows the genome locations of genes coding for enzymes in the pathway. Mouse over a gene to identify it. So this circle is the E. coli chromosome, which is circular. Next, the gene regulation schematic shows us the genetic regulatory influences on each gene in the pathway. Each gene is a circle. These are the regulatory genes, and these are the pathway genes here. So the pathway genes are actually boxes. The green arrows indicate activation, purple blunt arrows indicate repression, and the brown arrows indicate either repression or activation depending on the circumstances. So for example, TYRR represses TYRB. Self-regulation is denoted by these internal arrows. So for example, FOB activates itself. Continuing down the page, we have the Ontology Classes to which the pathway is assigned, and we have a mini review summary that our curators authored. We have a notion in BioCyc of base pathways, of which tyrosine biosynthesis is one, which are metabolic pathways that we have chosen not to divide into smaller units. We also have a notion of super pathways, which are defined linked clusters of related pathways. And subpathways are the smaller pathways from which super pathways are created. So if you would like to see the super pathway of charismate metabolism, you would click right there. The next section of the page shows the credits of what curators have worked on this pathway. It shows when the pathway was created, when it was last revised by a curator. So there shouldn't be missing literature older than this last curated date. All literature about the pathway up until that date should be covered in the curation. Finally, we have the references section, which is divided into two parts. The first part lists the references in this pathway page. The other part lists references in related pages for genes and enzymes and subpathways and metabolites related to this pathway. Now, let's next explore the right sidebar menu, which lists a number of useful operations for pathways. For example, we can download a list of all the genes in the pathway, which that could then be input into some other bioinformatics software package. And we can also download the BioPax definition of the pathway. We can also display the pathway in the large cellular overview diagram that shows the full metabolic map of E. coli in this case. And we can see the pathway is highlighted down in this green area. And another of our webinars described this diagram in more detail. Let's go back to our pathway page now. We can also customize the pathway diagram with this command. And this gives us many different options for changing the pathway diagram. For example, we could remove gene names and we could remove EC numbers from the diagram. And let's click OK, and it will redisplay the pathway without gene names and without EC numbers. And a whole host of other customization options are available, such as changing the text size, changing the layout of linear pathways to be horizontal or vertical on the page. We can also superimpose omics data onto the pathway, gene expression or metabolomics data, or a mixture thereof, by specifying a file containing the omics data, what columns of omics data to use from that file, and what format to display the data in. So this option allows us to superimpose omics data, and we're going to upload the data from a new file. And here we'll browse to the file on our file system. Now, the first column of the file contains, since this is gene expression data, gene names and identifiers, and we're going to have it use columns 4 through 7 to produce the display. And these data values are a 0-centered scale, and we're going to display the omics data in pop-up windows using the vertical bar chart format, although there's some other formats available. And let's click OK. And it's now reading in the data from our file, and it has created these pop-up windows. Let's scroll it so that you can see it. And we can reposition these pop-up windows to make them more visible so they don't overlap other parts of the pathway diagram. We can also remove them by clicking the X's. And so these diagrams show the gene expression values for each gene in the pathway in this case. Here is what the omics data file that we just read in looks like. The pound characters indicate comment lines that the software ignores. It's these lines that contain the real data, and the first column, which by the way is numbered column 0, contains gene names or identifiers, and the other columns, which are numbered 1 through 8 in this case, contain data values, and the columns are tab separated. The final part of this webinar will show you how to produce and manipulate pathway collage diagrams. A pathway collage contains a set of related metabolic pathways, optionally overlaid with omics data. And you can customize the display of the diagram both stylistically and by controlling the relative positions of the pathways. We'll start by finding the pathway for charismate biosynthesis. We'll go to its pathway page, and now we're going to click Generate Pathway Collage on the right side. So the pathway diagram has been sent to a new application in our web browser that we can zoom and move around. And what I'm going to do is to right-click, that's our first pathway. I'm now going to right-click on the compound charismate and add some additional pathways to the diagram. I'm going to select three more pathways to add to the diagram. And let's again zoom them down to make it a little easier to move them around relative to one another. I'm going to move them around like so. And let's now zoom in a little bit, and we can see that each of these pathways involves charismate, and one thing that will make the pathway diagram a little more pleasing, I think, is if we merge the charismate node. So in other words, let's just have one node for charismate itself. So I'm going to click merge for these as well. Okay, and now we can do a little bit more repositioning to make the diagram a little more pleasing to look at. We can move the pathway diagrams around relative to one another. Okay, let's now consider some of the display customizations that we can perform. And those are available under the View menu under Customize Global Properties. We can begin by adjusting the font size of the metabolite labels, like so. And we can change the colors of the metabolite labels. Okay, there we've changed the color. We can also change the shape of the metabolite icon. So the icons are the little shapes associated with each metabolite. And if we want to get rid of those completely, we can change the opacity to 0. That will remove the icons. We can also remove enzyme and gene names from the diagram if we wish by clicking that on and off, and we can change their color and change their font size. And if we go to the pathways area, we can remove the display of the pathway labels, or we can change the colors of the labels. So we prefer to have reddish labels, we could do that. And we can also, if we go into Other, we can change the background color or have it use a transparent background for the PNG exports. Now if we exit from here, we can also add omics data to the collage diagram using this command in the File menu, add and replace omics data. And we browse to the data file. And once again, we tell it that in the first column of the file, we have gene names and identifiers. We tell it to use columns 4 through 7, and that the data values, again, use a zero-centered scale. We'll use our default color scheme. And what it does is to read in that full omics data file, and it replaces the enzyme names with the omics data. So each of the 4 time points that we specified, columns 4 through 7 of the file, become one little square in this grid. And we can now make this smaller or larger. Now, if you want to use this diagram in a publication, what we suggest is zoom it up to a very high level so you get very high resolution, and then export it to a PNG file using this command, and then include that high resolution PNG file in your publication. You can also save the collage to a file for re-import using the load command at some later time into your web browser. Thanks for listening. That's the end of the Pathway webinar.